In this video, I want to talk about solving a very specific type of problem that you are likely to see on the CSP exam. Again, 4 to 5 years from now, after you graduate, you're going to want to take the certification exam, and become a certified safety professional. And this is a type of problem you're likely to see. This is a problem that will require you to have a basic understanding of probability, a basic understanding of the addition or the multiplication rule as it applies to probability, and also to understand and know what a Venn diagram is, which I'm sure you've all covered Venn diagrams somewhere in your educational experiences. Maybe back all the way back to elementary school, you were exposed to Venn diagrams. But this is a good example of a CSP problem because it takes a lot of different concepts. It's testing you on a lot of different concepts. It's not just one thing. It's not just what is system safety or what is process safety management. You have to be able to use your knowledge in a lot of different areas to come up with the correct response. But again, this is what it might look like on the actual exam, a problem like this. You'll have the question stem, which is the words, and you'll have a diagram. And the diagram here is a Venn diagram. We have two circles representing two jet engines. Where they overlap is, well, I'm getting ahead of myself. Let me go back to the question. A twin-engine jet is designed to remain airworthy in the event of a single-engine failure. What is the probability of the plane landing safely? Or probability of success. And on the actual question that you see on the exam, it's not going to have that probability of success. I'm just adding that for clarity, for instructional purposes, but you're not going to have that. But again, the question stem, the Venn diagram, each circle in the Venn diagram represents a different jet engine. And it has information about the jet engine. The probability of failure, or P sub F, equals 0.1 for engine 1. Engine 2, P sub F, is 0.1. Where we have the overlap, where the two circles overlap, that is the failure condition. That is both engines failing simultaneously. If you go back to the question, that's what it says is required. It says that it's airworthy if one engine fails, but it's not airworthy if both engines fails. So, again, we need to take this information and come up with the probability of the plane landing safely, which is in essence the probability of success. We haven't seen this formula yet. It's so basic I didn't think it was really necessary to show it to you, but now it's applicable. Probability of success equals 1 minus the probability of failure. So to find probability of success, we need to use the failure data to calculate the probability of failure. Once we have the probability of failure, we go back to this formula and 1 minus that probability of failure. But first of all, probability of failure. Engine 1 and engine 2 have to fail for the engine to fail. Both engines fail, probability of failure equals 0.1 multiplied by 0.1. This is an AND situation, so the multiplication rule applies. This is our probability of failure. Now, once we know the probability of failure, we can use the probability of success formula with the probability of failure plugged in, and there's our probability of success, 0.99 or 99%. 99% chance that we're going to be able to land safely in this twin-engine jet. Which realistically, that's way too low. Aircraft are much more reliable than 99%. But again, this was just some made-up numbers for the purpose of illustrating a type of problem that you might see on the CSP exam. A type of problem where you'll need to know what a Venn diagram is, a little bit about probability, and the multiplication rule. All right, let me know if you have any questions about this problem, the CSP exam, or anything else related to the safety profession.